Today's lesson is on scatter plots. Scatter plots are used when we want to see if there's a relationship between two variables. So in this example, we are collecting information, collecting data on comparing the temperature to the sales of ice cream. So we're just going to collect information. We're going to collect information on temperatures and then sales and see if there's a correlation between the two variables. So in this, as you can see, as temperature increases, so do our sales. So we would say there is a correlation between my two variables. And as you can see, the data, not perfect, but kind of follows a linear pattern. So we collect information, we plot the information, look for a correlation, and if there is a correlation, we find this line of best fit or trend line and write an equation for that line. And then we can also often use our equation to make predictions for the future. All right, so within scatter plots, we have correlation coefficients. So this is a number that we give to a scatter plot that describes the correlation between our two variables. Correlations can be positive or negative, strong or weak. A positive correlation just means increasing, and a negative correlation simply means decreasing. And then we have strong or weak. Strong would be correlations that represent a linear function, or at least close to a linear function. So as you can see, we've got strong correlation here, strong correlation here. A weak correlation would look here, like there's still, you can see there's a correlation through our points, but it's not quite as strong as here. And then this would be like no correlation. All right, so the correlation coefficient, the number that we give to describe the correlation of a scatter plot, are numbers in between -1 and 1. If the correlation coefficient is exactly 1 or -1, that means it is a perfect linear function, perfectly straight line. 1 is increasing and then 1 would be decreasing. So if the closer you are to -1, that would represent a strong negative correlation. So the word negative is not bad, it just means decreasing. And then the closer you are to the number 1, that would be a strong positive. And the closer you are to 0 would represent no correlation. And usually, 0.7, 0.8, 0.9, those would represent strong correlations. I'd say, 0.5, 0.4, 0.3 would all be weak correlations. And then obviously the closer you get to 0, no correlation. So here are 3 different scatter plots, and we are simply just going to describe the correlation. And you always pick 2 words. So you have to decide strong or weak, and then you have to decide positive or negative. So let's find the strongest one of the 3, which I think is the middle one. So this is definitely strong, and it is increasing. So let's say strong positive. Let's see, the first one, I can see a linear trend, but it's not quite as strong. Let's say weak negative. And then here, so I guess right in the center, we see some lines that make a straight line, but overall they're pretty scattered about. So I'm going to say no correlation here. So here I have a scatter plot, and what I'm going to do is draw a line that best fits the data graphed. So that line is called a trend line or a line of best fit. And in this case, you kind of have a variety of how you draw your line, variety of options. And then once we draw our line, we're going to write an equation. And here it says by hand, because I'm also going to teach you how to write these equations using your graphing calculator. But for now, by hand. So I first just want to show you that all the varieties for drawing your trend line. What you want to do is you want to draw a straight line through your points. And you want to try to hit as many points as possible. You want probably the same amount of points above the line as below the line. So I'm going to show you a few options. If I draw a line here, I go through 3 of the points. I have 2 above it and 2 below it. Let's see, I could try to draw a line here. So that's still trying to go through the middle of all my points. Now, these 2 lines are, quite different. So when we make equations by hand, everyone's equations could actually be different because we could all be drawing different lines. It will not all be perfect, but that's why we show our work so that we understand the process. All right, so I estimated these points to be at -640 and then 0, 110. So I'm first going to find the slope between my 2 points. So I need to do 110 minus 40 over 0 minus -6, which would go into 0 plus 6. So I have 70 divided by 6. And 70 divided by 6 is, well, we get a decimal. So for this case, we can either simplify it to 35/3, or in scatter plots is really the only time I do kind of accept you to round a decimal, so let's go 11.7. After you find your slope, we now have to write the full equation. So let's point slope form. Let's use our first point and our slope. So y minus 40 equals 11.7 times the quantity x plus 6. So let's now convert it to slope-intercept. So let's distribute. And then let's add 40 to both sides. And we get 11.7x plus 110.2. So yes, I do realize that the point I picked actually is my y-intercept, 110. But I wanted to go through the full process of point-slope form, because you'll not always be given a point right on the y-intercept. So you actually have to go through the whole point-slope form to get the y-intercept and slope. So here is the equation of the trend line that best describes the relationship of these points on the scatter plot. All right, now we're actually going to practice drawing a scatter plot and a trend line, and then we're going to write another equation of our trend line. So here we have a function table. We're looking at years, and then the U.S. unemployment rate. So whenever we have years, you can always use the full year on your graph as part of your coordinate points. So you might have the point 1988 for the x, and then 5.5 for the y. However, there is a conversion that you can do. You can say that the starting year represents 0. And then all these would be how many years after the starting year. So 1989 is 1 year after. If you look, 1994 is 6 years after. 1998 is 10 years after. So in this case, they all go up by 1. So I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You just have to be careful because the years in examples might not always go up by 1. So your conversion, you'll just have to make sure you're always counting how many years after the starting year. So this conversion just makes it a little easier to work with so you're not working with such large numbers of the years. So instead of 1988, it would be the point, 0, 5.5. So here is a scatter plot of this function table. You'll want to pause the video so you have time to get the whole scatter plot drawn. Make sure you always label your x-axis, so this case years, and your y-axis, this case unemployment rate. So as you can see, I converted my years into just the 0, 1, 2, 3, 4, 5 through 10. And then here is my unemployment rate that really ranges from like 4 to 7.5. But I started at 1. So when you draw your scatter plot, and then I drew a trend line. So as you can see, these 3 points are kind of way off from our trend line, but these points have a pretty good correlation. So what we're going to discuss, and more so once we get the calculator out, is how these 3 points negatively affect the correlation and what happens when we get rid of those 3 points. Alright, so if we look at the scatter plot we just drew, we have to describe the correlation of the scatter plot, and we're going to write the equation of the trend line. So really, if we include these first 3 points, I would say it's kind of a weak correlation. But if we just disregard those 3, I'd say it's a strong correlation. So for this example, let's say it is strong, and then they're decreasing, strong, negative. And now we're going to write an equation of that trend line. So I drew my trend line, and I made sure to go through some of my points. So to write our equation, we just need to pick 2 points to start. So let's pick 2 points right on the line and figure out what they correspond to on the function table. So the 2 points that I am picking are the points 6, 6.1, and then the points 10, 4.5. So first step when we have our 2 points is we need to find the slope between those 2 points. So 4.5 minus 6.1 over 10 minus 6. So we should get negative 1.6 over 4, and then divide, and we'll have negative 0.4. So that is the slope of my line. Notice it's negative, which makes sense because I have a decreasing line. So now I'm going to pick one of my points. I'll just pick the first one and use that first point and my slope and plug it into point slope form. So y minus 6.1 equals negative 0.4 times the quantity x minus 6. And then let's convert it over to slope-intercept. So here's what I get after I distribute. And now I have to add 6.1 to the other side. Alright, so the equation of my line is y equals negative 0.4x plus 8.5. Alright, I'm going to go look at my graph again. Hey, notice the y-intercept on my graph is about 8.5. So it's pretty accurate, at least for the equation of my trend line. So now this next part is a big part of scatter plots and why we do them. So we collect information. We look to see if there's a correlation between variables. We write an equation of the relationship, and we use our equation to make predictions so we can plan for the future. This process is used all the time. So in this case, we are going to use our equation to make a prediction that with this trend, what is the U.S. employment rate? Well, it's unemployment rate, actually, in 2015. Let's add that in there. That's kind of an important part. Unemployment rate in 2015. So 2015 represents years, which represents an x value. So we have to plug in an x value in for x of our equation and solve for y. But we're not plugging in 2015. 2015 is how many years after 1988? It's 27 years later. So we're going to plug in 27 into our function. So if you plug in 27 into the equation, we get negative 2.3. So stop and think what that means. That based on this trend, we're predicting 27 years later, the unemployment rate will be a negative number. So, in this case, that doesn't make any sense. And I wanted you to realize that, so one, this is used all the time, and it is a great tool for predicting the future. However, some things in the real world, like an unemployment rate, cannot just decrease forever and can never go negative. So just understanding that in a real life scenario, it's used all the time and it's a great tool, but understand that sometimes you're going to get things that just don't make any sense. Because unemployment rate, there's a lot that goes on in our world that's going to affect the unemployment rate to go back up and back down, but it still can be used to look at trends and make predictions of the future.